Hey, my name is Felipe and welcome to my channel. In this video we are going to train an image classifier using TensorFlow 100% online without using any code whatsoever. We're going to use Teachable Machine, which is a tool made by Google, and we're going to train a super robust image classifier in only a few minutes. Now let's get started. So let's start with this tutorial, and this is exactly the website we are going to use in order to train this image classifier 100% online with no code whatsoever. Now let me show you the data we are going to use today. We're going to use exactly the same dataset we used in one of my previous videos where I show you how to train an image classifier using YOLO V8. We're going to use a weather dataset, and these are the 4 categories we have in this dataset. The first category is cloudy, and you can see how the images look like. Now if I go to the other category, it's rain, and you can see that these are pictures of super rainy days. Now if I go to shine, which is the third category in this dataset, you can see that in each one of these pictures we have the sun, which is super bright, super up in the sky and super huge. And now the last category is sunrise, where we have pictures of many sunrises. So this is exactly the data we are going to use today, and remember we have already used this dataset in one of my previous videos. Now let's go back here. You need to go to teachablemachine.withgoogle.com. This is exactly the URL for this website, and once you are here you need to press get started. Let me show you how simple and how straightforward this process is. It's going to be super quick, super simple, super straightforward, and in only a few minutes we will have a model, an image classifier, which we trained 100% online with no code whatsoever. Now you can see that you have 3 different options, and we're going to select image project and then standard image model. The first thing I'm going to do is I'm going to name my classes. I'm just going to name them correctly. One of them is cloudy, the other one is rain. Then I'm going to add 2 additional classes. The classes are named shine and sunrise. And once I have created my 4 classes and I have just named them all properly, I am going to upload my images. So I'm going to click in upload, choose images, and now I'm going here to the weather dataset, the train set. I'm going to select all my cloudy images, and then I'm just going to wait, and that's it. That's how simple and how easy it is to load all the data into each one of these categories. I'm going to do exactly the same for the rainy category. I'm just going to select all the rainy images, I'm going to press enter, and that's it. Now I'm going to do exactly the same for the other 2 categories. For the shine category, it's something like this. And then for the sunrise category, we are going to do exactly the same, and that's pretty much all. That's pretty much all it takes to load all of our data, to name all of our categories properly, and to take all of our data into this platform. That's exactly what we need to do, and that's how simple this process is. Now the only thing we need to do in order to train this model is to press this button, train model. You get the idea, right? You get the idea how simple and how straightforward everything will be today. But before training this model, I'm going to make a very small adjustment. I'm going to press this tab over here, which is advanced, and I'm going to change the number of epochs. I'm going to train it for 10 epochs, so we can see how we go from there, right? I'm going to train it for only 10 epochs. I'm going to press train model, and that's it. The only thing I'm going to do now is I'm going to wait. I'm going to wait until this training process is completed, and this is going to be super amazingly quick, right? This is going to be a very quick process, a very quick training process. Now it's training, and you can see that this is the first epoch, the second epoch, the third epoch, the fourth epoch, and so on, right? The 5th, the 6th, the 6th, the 7th, and you can see how fast everything is going. In only 15 seconds we have trained our model. In only 15 seconds we have trained our image classifier. Now it's asking for permission to use my webcam, because that's one of the ways in which you can make predictions by using your webcam, but we are not going to use the webcam in this tutorial. Now, the first thing I'm going to do before making our predictions, before making our inferences, is look under the hood. I'm going to press this button because if we have trained an image classifier, the first thing we need to do, if we have trained absolutely any type of machine learning model, the first thing we need to do is to validate this model, is to take a look how this model performs, right? That's exactly the first thing we need to do with a machine learning model before using this model. Now, if I look under the hood, if I look at these plots, this is the accuracy per epoch and this is the loss per epoch. Take a look that now we have two functions, right? We have a function in blue and a function in orange, and we have exactly the same here for the loss functions. And although we have uploaded only the training data, we have uploaded only one dataset, we haven't specified anything as a validation dataset or as a test dataset. It seems Teachable Machine, it seems this website internally somehow splits the data into a training set and a test set. It seems this is done internally because we haven't specified absolutely anything, because you can see we have two different functions. One of them is accuracy and the other one is test accuracy, and for the loss function we have exactly the same loss, and then we have test loss. So it seems this website internally splits the dataset somehow, and now we have two datasets, the training dataset and the test dataset. And let's do like a very simple validation process. Let's validate this training process in a very simple way, the same way we did in my previous tutorials. If you watched my previous tutorials, you will remember I always say make sure your loss function is going down. If your loss function is going down, it's likely everything is going well. Make sure the loss function is going down both in the training set and also in your validation set. And if we look at this loss function, you can see that in the training set everything seems to be going well. Everything it's going down, so everything seems to be going super well. But in the validation set, or actually in the test set, you can see that the loss function seems to be somehow stuck, and also it seems to be going up, slightly up, right? It seems to be going slightly in the up direction. And this is something I don't like about this training process. This is a situation that I don't like. Now, if we look at the accuracy, you can see that although both accuracies, the training accuracy and also the test accuracy, both of them are going up, you can see that the training accuracy is going up a lot. We are getting a 100% accuracy in the training set. And that's hardly ever a good situation, because if you are getting that high of an accuracy in your training set, it's usually a sign that you are overfitting your training to your training data. So that's hardly ever a good sign. I don't really like having such a high performance in the training set. And if I look at these two plots, I can see that we are definitely overfitting to the training data, because the loss function in the validation data is going up, and also we get a 100% accuracy in the training data. So this means the model is overfitting to our training data. So what I'm going to do now is I'm going to do a much shorter training, and I'm going to stop this training around here, which is around the moment, around the time the validation loss started to go down, right? It started to go up. So I'm going to do this training for only 3 epochs, and let's see what happens. So I'm going to press train model again, and now we're going to wait until we train a new model, and let's see how this new model performs. Okay, so this is the performance on the new model we trained. You can see that for the loss function, now both of our loss functions are going down, right? The training loss and the validation loss, or the test loss. And for the accuracy, we got a very similar accuracy in both of these sets. And for the training set, we are not getting a 100% accuracy, so everything seems to be better now. Now, we are just going to keep this model, and now I'm going to show you how to make predictions, right? How to take this model in order to make predictions. We have two ways to do it. We could do it on the same platform, we could do it 100% online, the same way we train this model. We could do it using our webcam, but what I'm going to do is I'm going to do it I'm going to upload a file. This is one of the ways in which we could make our predictions. So this is how I'm going to show you how to do it first. I'm going to my validation data. This is my data, which is my local computer. This is completely unseen data for my algorithm, for my model. So the model haven't seen this data before. And you can see that we are predicting this image as rain with a 99% score. So everything seems to be going well with this model we just trained. Now, this is one of the ways in which you can make predictions using this model. The other way is by going to export model, and here you have three different ways to use this model. You can use it in TensorFlow JS, you can use it as a TensorFlow JS model, so you can just put this model into something like a browser using JavaScript, and you can definitely use it from there. You can take this model as a TensorFlow model and use it from a Python script. For example, I will say this is the way we are most familiar with in this channel because we usually work with Python. And you can also take this model as a TensorFlow lead model and use it from a mobile device. You have these three ways to make predictions with your model, and I'm going to show you how to do it using TensorFlow. You can see that not only we can export this model into these three formats, but we also have something like a code we can use in order to make these predictions. So we have already all the code we need and we know exactly what we need to do in order to make our predictions. This is how simple and how straightforward everything is using Teachable Machine. Now let me show you. I'm going to download my model. I'm going to download this model as a Keras model. And then this says converting model once everything is converted, and it's just going to be downloaded. And in the meanwhile, I'm going to copy and paste. I'm going to copy this code and I'm going to paste it in a Python project I created for this tutorial. So the only thing I'm going to do is going to main.py. This is a file, a Python file I created in a Python project, and I'm going to press paste. And that is it. And that's absolutely all I'm going to do. I'm just press copy and then I press paste. So I'm pretty much not doing absolutely anything, you may notice, and this is how simple everything is using this website. Now if I go back here, you can see that now, and we have two files. One of them is called kerasmodel.h5 and the other one is called labels.txt. Now this is the model we have downloaded, and what I'm going to do is I'm going to take these two files and I'm just going to locate this file in the file system, in my file system for the Python project I have just created, right? You can see that this is the main.py file I have over here where I have just pasted absolutely all of my code, and this is where I'm going to take these two files which represent the model we just trained using Teachable Machine. Now this is just going to take a couple of seconds. You can see that now these two files are in my file system, are in my local computer. And now let's go to Python because everything is pretty much ready to be used. But we need to do like a very small edit, which is, you can see this file name over here. It says kerasmodel.h5. Everything is okay, but you can see that this is a capital M. The M is in uppercase. We need an M which is lowercase, right? I don't know why we have this typo, but we do. If you take a look at the model you have just downloaded, you can see that this file, it says kerasmodel.h5, but it's in lowercase. So that's the only edit we need to do, and everything else should work just fine as it is. Now I'm going here where it says image path, and here I'm just going to copy and paste the path to one of my images in the validation set, right? So I'm going here, val, I'm just going to choose one of the shine images. I'm going to choose shine 1, so I'm going to do something like this and shine1.jpg. And now the only thing I'm going to do is I'm going to press play, and that's it. And that's all we need to do in order to make our predictions using Python with that TensorFlow model we trained using this website. That's how simple everything is. Now, obviously, while we are waiting for our predictions, everything is just completed. You can see that we are getting shine exactly as we should with a 99.4 confidence score. So everything is amazing. And what I was going is that remember to install this project dependencies, remember to install all these packages, because otherwise it's not going to work. You can see here at the top we are using Keras, Pil, and NumPy. So please remember to install all these packages, which are Pillow, NumPy, Keras, TensorFlow, and also scikit-learn, because we are going to do another edit. Because I think it's very interesting. We have this code in order to make predictions on individual images, so we get an idea of how this performs on an individual image. But let's see how it performs on the entire validation set we have over here, right? Remember, in one of my previous tutorials I showed you how to make an image classifier using YOLO V8, and we used exactly the same data. So let's just compute what's the accuracy on the entire validation set, so we can compare this model we trained with the model we trained in one of my previous tutorials. And in order to do so, I'm going to just make a few small edits. The first one is going to be define a new variable, which is root directory, and this is where I'm going to specify the path to the validation dataset. So I'm just going to press paste, and that should be all. Okay, so this is root directory, and now I'm going to iterate in all the directories within my validation data, and then I'm going to iterate also in all the images within each one of these directories. And this is how I'm going to do. For dir in os list dir root directory, obviously I need to import OS, otherwise this is not going to work, so import OS. And then for j in os.listdir os path join root directory dir, and that's pretty much all. Okay, and then I'm going to define another variable, which is image path, and this is os path join root directory dir and j, and that's pretty much all. Now I'm going to edit this value over here, and I'm going to change it by image path. And now we are reading the image path, we are reading absolutely every single image in each one of our directories in the validation data. So the first thing I'm going to do is to make sure this executes properly. And once we make sure everything runs super smoothly, I'm going to make some additional edits. But for now, let's see if this is just okay, if this runs super smoothly. Okay, we are getting predictions, so everything is just fine. And now what I'm going to do is I'm going to save all of my predictions into a list. So I'm going to create a list which is called predictions, and then I'm going to create another list which is called labels. And this is where I'm going to save all my predictions, and this is where I'm going to save all my labels, right? Now I need to import an additional library, an additional function, which is from sklearn.metrics import accuracy score, right? Because I am going to call this function in order to get the accuracy score of this model in absolutely all my validation data. And by calling this function, it's going to be super straightforward. Now I'm going back here, and what I'm going to do is I'm going to append. This is the index, so this is the value we need. This is the integer we need in order to make have our classification, in order to have our predictions. So I'm just going to say predictions.append index. Now I need to append the label for these images, and in order to do so, let me show you something first. These are our class names. If I go back here to this project file system, to this project directory, you can see that if I open this file, is the labels.txt file we have just downloaded from Teachable Machine. And you can see that we have 4 values: 0 cloudy, 1 rain, 2 shine, and 3 sunrise. So these are the category names, and these are the indexes, right? So once we are saving all the data into predictions and into labels, we need to make the predictions and the labels into this format, right? We need to append these values. Now, our labels, currently, the way we are iterating all these directories, our label is here. It's in the directory name, right? if I go back here to the validation data, you can see that to the validation data, to the root directory of the validation data, you can see that our labels are actually the directories names. So we need to make some process, we need to make some function or something to take this name and to return this index, right? It's very straightforward, it's very easy, but we need to do it first. Now, this is how I'm going to do. I'm going to print class names. I'm going to print this variable, which is actually the this variable contains all the information we can see over here, but let's see exactly how this information looks like. So I'm just going to press play, I'm going to print this variable, and then I'm going to continue. Okay, and now I'm just going to press stop. You can see that this is the variable we print, and this is how it looks like, right? So we have 4 elements. This is a list with 4 elements. They are called, the elements are called the 0 cloudy, then 1 rain, 2 shine, 3 sunrise, and then for each one of these elements we also have a new line character, right? That's very, very important. So I'm going to create a variable, I'm going to create a dictionary, which is something like category to index, right? This is going to be the name, and this is going to be a dictionary. Then what I'm going to do is I'm going to iterate in all these elements in this list. So this is going to be something like for class name in class names, and then I'm going to say something like category to index. First I'm going to say something like class name dot split, and I'm going to split it by the space, right? Because I want to get these two values, the index in one variable, and then I want the category name in the other variable. So I'm going to say something like this, and this is going to be index and name, right? So I'm going to say something like this, and then I'm going to say that name is equal to name except the last element, right? Because we get that the last character is a new line character, and we don't really care about that character. And now I'm going to say this, category to index name equal to index, right? So now with this new variable we have just defined, it's super easy to do something like this. I'm going to labels append category to index dir, because this is the label of the image we have just read over here. So this is how simple this will be. Now I'm just going to press play to make sure everything executes properly and to make sure we don't have any error. And then it's going to be super easy, because the only thing we need is to call accuracy score predictions labels, right? But let's take it one step at a time. Let's see if this executes properly. Everything seems to be okay. And now let's see what happens. I'm going to print the accuracy score on the validation data with the model we just trained using Teachable Machine. Let's see what happens. Okay, so we got an error, so I think I know what's the problem. And this is the problem, that we need to say this is int, right? Because we need to compare integers to integers, otherwise this is not going to work. Now I'm going to press play again and see if that was the problem. Okay, so now I didn't get any error, and this is the value we are looking for. We are getting a 98.6% of accuracy in our validation data with the model we trained. And remember, this is completely unseen data for this model. We didn't use these images in order to train this model. So this is amazing. This is an amazing performance. So this is going to be all for today. My name is Felipe, I'm a computer vision engineer, and these are exactly the type of projects I make in this channel. So if you enjoyed this video, I invite you to click the like button, and I also invite you to subscribe to my channel. This is going to be all for today, and see you on my next video.